All right, guys, so we're gonna go ahead and find the volume of composite solids. Okay, so in general, just like when we're doing composite figures or the surface area of composite solids, all you have to do is just look at the two different figures. Okay, so in this case, we have basically two cylinders. We have our cylinder, the big one, and then the little one inside here, right? The thin one. And the reason it's with dotted lines is because it's representing that there's like a hole through it. So imagine like a roll of toilet paper. That's what's representing. And obviously, in this scenario, we're not going to go ahead and add the volumes. We're going to subtract them. Okay, so we're cylinders. There's two of them. So again, you could redraw them if you want. And on the big cylinder, oh, there's a number here in the bottom, right? They're telling us that the diameter is 16, and therefore I know that the radius is just 8. The height is 30, right? So, all right. And the smaller one, right, minus the cylinder, we know that the diameter was 4, so automatically that tells us that the radius is half of that, which is 2. And the height was the same, so again, the height is still 30. Well, according to the formula for volume, if it's a cylinder, volume is the area of the base times the height, and that's it, right? Volume is area of the base times the height. So we just substitute now. If I want to find the area of the bigger one, the volume of the bigger one, it's going to be big B. Again, big B, since it's a circle, remember to calculate big B, it's going to be pi r squared. So I'm going to have here pi times 8 squared for big B. On this one, I'm going to have pi and 2 squared. And they're both going to be multiplied by 30. Which, later on, I guess, you're learning some other math courses, that it might be easier just to put them together, factor things out, and it'll make your life easier. But for now, we have here that this is just pi times 8 squared, right? So big B on this one is basically 201. Whoops, that's not what I wanted. Oh well. And then for the other one, we have pi and then 2 squared. So big B on this one is 12.56. So again, volume, it's going to be 201 times 30. Volume here is going to be 12.56 times 30. So 12.56 times 30. So the volume of the smaller one is 376.8. The volume of the big one is 6,030. Right. Sorry about that, guys. And again, we're just going to subtract big minus small. So this one minus that other one. And so the total volume here is 5,653.2. That's my total volume, because we just subtracted them. All right, next one. We look at this next one. This is basically a trophy. It's a basketball trophy. All right, so let's say your team won the championship, and first place was gonna get a golden trophy. So obviously, This has to get created. So usually what happens is, and again, it all depends on what kind of trophy company you go to, but odds are they're not gonna make this out of pure gold, right? They'll probably make it out of brass or something, and then just, I don't know. It'd be lame if they painted it, but maybe a little coating would be nice. But anyways, we need to find the volume of gold or whatever that we need. Okay. So again, break it up into different shapes. We have a sphere, we have a cylinder, and we have a prism. And so that's all you gotta do. So for the sphere, our radius here is 5. And again, to find the volume of a sphere, we said that recently. Let's see. It's right here. Our volume was just this 4/3 pi times radius cubed. So I could easily calculate that. I just plug it in the calculator and I'll get what my volume is for my sphere. For my cylinder, again, I know my height is 6, and this little 1 represents the diameter, so I know that my radius is 0.5. And I just showed you the formula above. So the volume of a cylinder is big B times h, where B is the area of the circle, so pi r squared. And then times the height, right? So here this would just be pi and then 0.5 squared times 6. Again, easy calculation. And then for my rectangular prism, these are very easy to calculate. Right. I'm going to draw it slightly different, but it's the same thing. All right, so my base in the bottom is a 5x5. Okay, so again, volume on these is just big B times h, which translates just to length times width times height in a rectangular prism. So it's just going to be 2 times 5 times 5. So this is going to be very easy to calculate. So now I'm just going to go to my calculator and find out each one. So I have here this 4/3 times pi times 5 cubed. So this one gives me 523.6. The units are inches cubed. The next one gives me pi times 0.5 squared times 6. So this one gives me a volume of 4.7. This one's small, but that's normal because the radius is really tiny. 4.7. Again, units cubed. And then for the other one, it's just 2 times 5 times 5. Here, the volume is 50. Okay. And here this was supposed to be cubed. Okay, let me go back and check that I cubed it in the calculator. 4/3 pi, 5 cubed. Yeah. Okay, that's a big one compared to everything else. But anyways, all you would have to do at this point is simply just add them up and you'd be done. Okay. I found this problem over here that I really wanted to talk about. I just want to talk about it conceptually. Sometimes, they go into these problems when they're dealing with optimization. You've seen how tennis balls, when you buy them at the store, they usually come in a cylindrical container. And again, everything's with a purpose in mind. And I guess if you think about it, it's mostly due to the empty space that's there. Okay, the least amount of space, the better, because you are using, I guess, the volume to its fullest. Now, um, so in this problem, if you know that each tennis ball has a diameter of 3, that means that each radius is 1.5. Okay, and assuming that this is a perfect cylinder, right, and that the balls are very snugly fit, then the radius here is also 1.5. There's 3 of them. Okay, so this cylinder has to be at least, right, so this is 3, 3, 3, this has to be at least 9 inches tall. So let's say I wanted to find the volume of my cylinder. So I find my volume of my cylinder. My radius is 1.5. My height is 9, right? And again, we already said that volume of a cylinder is basically pi r squared times the height. So I come here and I just calculate pi times that 1.5 squared times my height, which of 9. So the volume here is 63.6. Each ball right there, let's find out what the volume of each ball is. Again, volume in a sphere is just 4 over 3 pi radius cubed. So it's going to be 4 over 3 times pi, and then the radius is 1.5 cubed. So each ball has a volume of 14.137, right? Anyway, so there's 3 balls in there, right? So I'm going to multiply it by 3 to see how much volume there is in total. So the total volume of the balls there, right, is 42.4. Considering how the cylinder itself has a volume of 63.6, let's find out how much is not being occupied in the cylinder. So 63.6 minus 42.4. So we're quote unquote wasting 21.2 inches squared, right, of area in my container. Which, I mean, I couldn't fit a ball there if I wanted to, maybe about half, but still, that wouldn't be cool because it's going to have to be cut into super tiny, weird little pieces. Be useless. But yeah, just again, think about the total possible ways you could end up using this, guys.